Welcome to Commonplace Expertise, where we take a look at the expertise that exists in the heads of the most interesting people around us. These conversations are meant to help you make better business and career decisions, and I hope you find them useful. Today I'm speaking to David MacIver. David is most known for pushing the adoption and ergonomics of property testing in software with his testing library, Hypothesis. Hypothesis is well regarded and widely used in the Python programming language community, and it introduced a handful of innovations that are now quite widespread in the practice of property testing. You hear more about Hypothesis during the podcast as we talk about what he's learned pushing the boundaries of a domain. Then we shift gears to talk about his coaching practice. David specializes in helping programmers with self-improvement, more effective learning, and developing soft skills, which many computer programmers are likely to struggle with in ways that may limit their careers or their personal development. I hope you enjoy my conversation with David MacIver. Hi, David.
Hey, Cedric.
All right. So to get started, I was sort of thinking about how to open up this podcast, and I thought a good way is to sort of ask you about Hypothesis. Like, what is Hypothesis, and how do you get into building this thing, which in many ways, for those of you who don't do software, maybe explain it for those people, and then sort of like talk about the story of like how you got started building Hypothesis.
Sure. Yeah. So the explanation I usually give for non-software people is I start by telling them a little bit about software testing, which is when you've written a piece of software, you want to know that it does the right thing. And one way you can do this is you can basically just manually poke about at it and see whether it looks roughly right. But then you make some changes, and you have to now redo the entire manual process over and over again every time you make some change. This is slow and tedious. So what we do is we write software tests, which are essentially just a little program that automates the thing that a human would do. It runs through a set of predefined actions on the software, and it checks that certain things have happened. So, for example, it says, log into the website, click this button, you should see this piece of text on the screen, that sort of thing. This is fairly simplified, and like a lot of software tests don't run the full application stack, but that's the basic idea. And the problem with these software tests is that like they don't really help you out in any way other than like what you would already do by hand. And so Hypothesis is a piece of software that helps you write software tests that in some sense actively go out looking for bugs in the software by letting you generate a variety of actions that the software can perform on this. So for example, with our log into the website and click this button, and you should see this text on the screen, you might want to vary the sort of the details of the user you're logging in as. You might want to sort of try a variety of different names for the user. You might want to make sure that it still works if they've got accents in their name or Chinese characters or the like. And so you end up running, and it can get more complicated than that. But basically, Hypothesis generates data for use in software testing and potentially generates a variety of different actions and tries to use this to explore your software in a way that it can find bugs that you wouldn't have found by hand without a lot more manual testing than you otherwise would have done, than you want to do.
What made you interested in this particular problem in the beginning?
So it happens more or less by accident. So Hypothesis is descended from a library in a software library which does similar things in another programming language, and the other programming language is called Haskell, and the original library that Hypothesis is based on is called QuickCheck. I had used another library. I hadn't used QuickCheck very much, but I had used something else called ScalaCheck, which is QuickCheck but for the programming language Scala. And so I was already like reasonably familiar with the basic ideas. And then I think I'd been talking to someone about property-based testing, which is what this type of testing is called, at a conference. And shortly after that, I was moving jobs, and I needed to learn a new programming language, Python. So I was just like, what? I wanted a toy project to write in Python, and a quick check port seemed like a reasonable thing to do. So I wrote the very first edition of Hypothesis, which then sort of languished in not quite obscurity for a few years, because I'd sort of I'd left that company. I'd moved on to Google, where I couldn't really work on it, and in the sort of the meantime, people started using. I'm sorry, this is a very long story, by the way.
This is a good story.
Yeah, okay. Well, yeah. In the meantime, people started using Hypothesis because like there were a bunch of other quick check ports to Python, but none of them were very good. And neither was Hypothesis. Hypothesis was very bad, but Hypothesis had one fairly crucial feature that none of the others had, which is what's called shrinking in quick check language, or test case reduction, is to use the general term, which means that when Hypothesis first finds a bug, it will have like, here is the username that triggers the bug in the login form, say. Then like the first thing it tried might be like this horrible 200 character or nonsense string. And what will happen with Hypothesis is it won't stop there. It will say, okay, what part of this string actually matters, and try to make it smaller and simpler. And so eventually, like, you'll probably end up with a name that just has the one character that causes problems.
And so, just a sense of the timeline. What year was this?
So that would have been 2013, I think.
And how many years after you started the library?
No, I'm sorry. 2013 was when I started the library.
Right.
But Hypothesis had shrinking from the very beginning.
Wow.
And the reason was basically because I had already like used Scala check extensively, so I knew just how annoying property-based testing is without shrinking. To be clear, shrinking is not my invention. Shrinking is something found in quick check and Scala check and most of the good quick check ports. But
right.
But shrinking is also quite hard to implement, so many of the bad quick check ports don't have it, and they're sort of borderline unusable as a result.
So I'll tell you why I'm interested in, and why I started the conversation with your work with Hypothesis. In our conversations, right, you've mentioned that in many ways, Hypothesis, you have like moved to the very edge of property testing, and in many ways, like the work that you've done with Hypothesis has pushed forward, I think, the adoption of property testing in general in many programming languages. And some of the techniques that you came up with during the work that you did on Hypothesis is now sort of like, you know, they're in the air. And so I want to sort of dig into like what that was like, right? Like, could you sort of talk a bit about what were your contributions and what was the state of the art at the time, and like, where do you push it towards?
Sure. So I should say, like in 2013, Hypothesis was very much not the state of the art. It was like it had a weird API. It was kind of clunky, and it had all of the limitations that other implementations had. So the thing that I've pushed the state of the art on is basically the shrinking aspect of it. And the problem that you have in a lot of there are two things in Hypothesis that are, I think, state of the art, and they are both usability improvements rather than they're both usability improvements. I don't want to couch that because like this is why Hypothesis is sort of driven a lot of adoption of property-based testing, I think. Certainly a lot of adoption in property-based testing in Python. Like, I think it's fair to say that property-based testing would not be a thing we used in Python if it weren't for me. But one of the problems you have in property-based testing is that you generate an example, a test case for testing the software application, and you need to make sure that it's the right sort of example. So, for example, if I were to generate something that wasn't a valid login in some way, let's talk about sign up rather than login. Say I generated something where I was signing up for a website and I sort of filled in all the details on the form, and it asked me to put in my password, and then it asked me to confirm the password again. I have to make sure that the two values are the same in order for this to work, and the website has to be able to work if the two values aren't the same, but in the sense that like it should correctly reject it. But if my test is sign up for the website, log in, do this thing, then it will fail at the point of sign up if the two password fields are not identical. So this is what's called a validity criterion. It's a test case can be invalid in the sense that it doesn't do the things that are needed in order to test the thing that it's supposed to test. And often it's very easy to write things which are where you guarantee that you're generating a valid thing up front. So for example, you could generate a valid sign up there by generating a password and then saying you reuse the same password for the next one. But classically, the way shrinking worked is that it took the test case that you had generated and it tried modifying it. So it tries cutting bits out of it. It says, okay, what happens if we make the password shorter, say? And it does this without knowing anything about how you generated it. So what would happen is that shrinking would try making the first password smaller and not the confirmation password, and now that wouldn't work. And depending on how you have the test set up, this can result in two different types of problem. One is just like shrinking may not be very good because it can't make the changes it needs to make, and the other one is that if your test is written a particular way, like it might cause the test to fail. Like it might you might get an error that says the form was rejected, and this might look like a failing test. And now what happens is you found a real bug in the generation case in time, but the shrinking then turned it into a fake bug that isn't a real bug, and now you get annoyed at the testing system. And so the change that, or the thing that I invented is it turns out that like there was some prior art, but it was good that I wasn't aware of this prior art, because it doesn't work very well, and I would have copied it otherwise. But like the thing I invented was a particular way of making sure that everything shrinking works through the generation system. So rather than, you can think of the test case generation as providing a recipe for how to construct a valid test case. Yeah. And the shrinking in hypothesis works through that generation system. So what will happen is it'll try shrinking the first password, and then it will know that it's still supposed to just copy that over to the next one. So as a result, people never have to really know how to write a shrinker, which was one of the problems that happens in classic weight check. And also the and also like the test cases produced will always be valid.
Interesting. So you said there were two particular ways, right? Which what was the second way?
Yeah, the second way is a way of generically remembering the test case for later. So what happens with hypothesis is if you rerun a failing test, it will immediately remember the way it failed last time, and it will just reuse that immediately.
Damn, yeah, that makes sense.
Yeah, and it's very obvious that that's a thing that you want.
Yes,
but it's quite hard to do for a couple of reasons. But the main one is a test case could be anything. There's not necessarily a nice simple format to write it to disk, and also and also if the test changes in some way, then it may be that the old test case is no longer valid for the new test. Like I don't have a very good example for that,
No,
but
it's all right. Like
yeah.
how so where I'm moving sort of like trying to figure out is to somebody listening to this who has never sort of, designed something from scratch or
Mm-hmm.
much less push something to the very edge of like what has been
Mm-hmm.
done before, right? What was difficult about this process? What were these sort of ideas? How hard was it for you to reach these two sort of major innovations?
Yeah. The honest answer is that it wasn't that hard. It's partly this was luck in that I had some good background for it, but a lot of it was that I was able to do this because not that many people had worked on this particular class of problems.
Oh, say more.
Because like people have worked on property-based testing, but sort of shrinking has always been treated as like a minor side note. And the reason I was working on them is essentially because I have like people were telling me that things were irritating about the library, and I was going, "You're right, that is irritating. Let me see if I can figure that out." So it was essentially research driven by primarily user experience goals. It was there was no sort of like grand research agenda. I was just listening to people telling me what was irritating and following on from and trying to help them with that. I think the remembering saved data examples thing, saved test cases was something that I wanted, and so I did that because I found it irritating to not have that, and that ended up being a surprisingly useful way into the idea that also provided like fully generic shrinking, and what happened there was that like there was an initial very bad implementation where basically what happened was that I wrote a bunch of custom shrinking logic and also had a fallback system where the version that you would serialize onto disk was something that you could, because you had to be able to serialize it onto disk, and you had to be able to check the thing you'd got from the disk was valid. So that was a format that you could do test case reduction on.
Oh wow! So it was like sort of like you reached that point and you realized that you could use that as well for
Yeah.
nice.
And then the sort of like the next generation version, which came in Hypothesis 3.0, I think. Yeah, it was meant to come in 2.0, but I couldn't make it as backwards compatible as I thought. So I ended up having to bump the minor version in again. Sorry, no, it wasn't meant to come in 2.0. 2.0 was a deprecation release to sort of remove a bunch of stuff, and then I turned out to have to remove a little bit more to get the full idea working. So 2.0 was very rapidly followed by 3.0, which had a universal format that worked for everything. So there is now just like a single format that is both the on-disk format and what shrinking operates on.
Right. So sort of two interrelated questions here. I think we've talked about this before, like how software design is very often like a step-by-step unfolding, right?
Mm-hmm.
Which was what happened here as well, right?
Yeah.
You wanted something to scratch, you built something to scratch your own itch, and then you modified it, and then you let your taste plus feedback guide the evolution of the software. But because this is a testing library, so like the first question is like, what were you testing it on? Like, were you writing like random test cases or like random websites to test on, or what?
It's a good question. So for the initial version, I would have just been running it on toy examples, basically. There's this sort of small list of examples that everyone uses, most of which I don't think are very good. Like your classic property-based test example, which I hate, is if you reverse a list twice, you get the same list back. but things of that ilk. So I think initially I just had a bunch of toy examples. Somewhere leading up to Hypothesis 1.0, which would have been in early 2015, I realized that it was sort of stupid to have a badly tested testing library. So I decided to go for 100% test coverage and just wrote a whole bunch of manual tests for it. Hypothesis is tested with itself in places, but I think it's not always a gimmick, but it's mostly a gimmick. There are a few things where Hypothesis has genuinely caught bugs in itself, but for the most part, Hypothesis is tested with itself because we can.
Right. And then, so like the second interrelated question is at what point do you know that you were onto something?
That's a good question. I think the point at which I did the insight that led to the sort of the 3.0 release, the universal representation, that was the point where I was just like, oh, this is actually genuinely novel in important ways. And so that's when I knew I was onto something from the research side. From the point of view of like whether when I knew I was onto something from the usage side, honestly, it's been a very gradual thing. It's I tried to push the usage a bit too hard, a bit too early, I think, and so I was trying to build a business around Hypothesis in sort of 2015, 2016, and I didn't do a very good job of that. So I think at the time I wasn't convinced I was onto something, simply because like I figured I would be having an easier time building a business if I were. But I think it's been a slow build and like gotten more and more traction as people have sort of heard about it. And I think at this point we've hit pretty good usage. I don't remember the statistics. I should have looked this up, but I think like JetBrains does this survey of Python developers, and a fairly gratifyingly large percentage of them were using Hypothesis at this point. It's like I don't think we're in the sort of the majority of Python users use Hypothesis or anything. Like I think it was probably more in the low double digits range, but
I think many companies use Hypothesis, if I'm not mistaken. I could you like if I'm not mistaken. So I had a friend who he's working in Google and he ran they have universal search and he found like Hypothesis inside the Google code base as well.
Yeah.
So yeah.
Yeah, no, I think it's true that there's at least like any big user of Python probably has Hypothesis somewhere in their code base. Like probably not. It's probably not like the major way they do testing, but it's. I think like anyone who is sort of very into software testing in Python either has used Hypothesis, uses Hypothesis, or Hypothesis is on there. Oh yeah, I keep meaning to use that, but I haven't been able to figure out how yet. When I think it's actually very easy to figure out how, but people think it's scarier than it is. And I think that's genuinely one of the big problems with adoption is that because Hypothesis has this Haskell quick check association, everyone assumes that it's like scary thing for people who are super into types and formal verification, when actually it's just software testing.
Yeah, I think sort of to speak to that, to like how broadly Hypothesis has spread. I remember your 1.0 release because at the time I was mostly writing in Python, and I think it was 2015 if I'm not mistaken.
Yeah, 1.0 was 2015.
Yeah, so I was newly in Vietnam, and I still subscribe to this Python mailing list where they sort of talk about the cool stuff, projects in Python, and Hypothesis was like one of the, it was the big sort of link or like the big project in that particular newsletter. So that's how I sort of stumbled upon that, and then I guess this is a nice segue to sort of like talk about. We'll circle back to the business in a bit, but I just want to get a sense of like maybe people should should hear like your story of like how you got here. Now that we've sort of covered Hypothesis, which is sort of one very interesting part of your life, but then now you're doing something very different.
Yeah. So after hypothesis, or after I failed to build a business around hypothesis, I ended up doing a PhD around it because I was just my haha only serious joke about this is that I was really enjoying the research and I was really struggling for the business with the business, and there's a place for people who enjoy research and struggle with the business. It's that didn't go so well, and I've quit the PhD now. But sort of at some point in the middle of the PhD, I was just like, I um, I sort of looked at my life and I was just like, you know what? I'm not very happy. That seems like something I should do something about. Um, and so I did what any self-respecting nerd would do when they sort of want to understand their feelings. I read a whole bunch of books. And um, so I, and like some of them were very much at the self-help, don't take too seriously end. Some of them were more at the like the serious therapy end. Some of them were just like a whole bunch of random life stuff. And so I started so I started essentially working on like trying to understand my own emotions, trying to understand life, the universe, and everything. And at some point, I think that must have been like very late 2018, and at some time, sort of early 2020, I was just like, okay, I've got all of these ideas in my head, and I've written about a tiny fraction of them. I should clearly fix that. And so I just started writing a huge amount on my notebook blog, which is just a place to put poorly formed thoughts, and people found it really useful. So I started a newsletter, and then and people found that quite useful, as apparently. I'm not making a huge amount of money off the newsletter, but like I got paid subscriptions, and people like it enough to pay me for my writing, which is honestly a weird feeling. And then back in September, um, uh, I sort of put out a small tweet basically saying, "So I've got all these like thoughts and useful skills. Would anyone like me to coach them? I could probably be a pretty good coach." And it turned out that quite a lot of people wanted me to coach them, which, again, slightly surprising, um, but that's been going pretty well. And um, earlier this year, I was having a sort of heart searching moment where I was just like, my PhD and my coaching are sort of getting in the or coaching and writing are sort of getting in the way of each other, and it's very clear that like there's one that I want to do and has a large positive impact on the world, and there's one that I don't want to do and doesn't have much of a positive impact on the world, and where I'm essentially like having to fight tooth and nail to. I mean, that's not entirely fair. I only actually made it got one paper published in the course of my PhD, but um, it was quite painful to get that published, and it just sort of made me dread the idea of trying to get another one undone. And um, and in the meantime, like there was all this writing that was getting like really positive feedback that was clearly helping people, and um, it just seemed much more sensible for me to focus on that. So I did. Um, and um, now I'm sort of trying to tie all of these themes together because, like, one thing that I've noticed that's interesting is that all of my no, all of my yeah, I think it is. I think currently all of my clients are software developers, and
Huh.
some of this is because I know a lot of software developers, and some of this is because software developers have money to pay for coaching. But but I think a lot of this is also that I've ended up with like the slightly weird niche of like explaining soft skills to software developers, because I have the right mindset for them, and I had sort of spent a lot of time learning to communicate well. And so when I take all of these ideas from therapy and self help and philosophy and feminist literature and political theory or whatever, and sort of try and go, okay, but how do I actually use those? The result ends up being something that is quite palatable to software developers because it's explained with like in relatively clear practical prose. Um,
Mm.
And so I'm currently sort of like trying to sort of turn this into more of a business focused thing where I go talk to software companies and software development teams and try and use the same skill set at the team level. But that's sort of early days, yeah.
I think you answered my follow-up question, which was like to sort of talk about what were the things that you were writing about that were so attractive to the people who were reading it. But perhaps to sort of like color that in a bit more,
Hmm.
could you give more examples, like some concrete examples of these things that really help the people who are reading them?
Yeah. So um, one of the things that I think has it's both a good example of like how much what I'm doing is explaining feelings to software developers is that I have this metaphor of emotional reactions as legacy code, um, uh, which is actually like very solidly grounded in actual therapeutic um, like theory, but is definitely like not how a therapist will explain it to you. Um, and so the idea is this: like an emotional reaction is or you're having an emotional reaction to do something. This is from a psychologist called Adler, who's sort of one of the original big three. He's like the fifth Beatle of psychologists, though, because people don't talk to him about him that much. You've got Jung, you've got Freud, you've got Adler, and there are others as well who I'm sure are important too. But I'm not actually. Anyway, so Adler's point is that like when you get angry at something, you get angry in order to behave in an angry manner. Like the anger is driving you towards a particular course of action and is enabling you to do so. It's um, and so the you can think of like your emotional reactions as a bunch of learned responses like this. You are angry because at some point you have learned that it is useful to be angry here, um,
Hmm.
and this works with other emotions as well. I think like some of them are less clearly driving you to a particular action and are more sort of like evaluative or judgment call all things. Like you can feel happy, and that doesn't necessarily mean you're driven to act in a happy manner. That's more of an evaluative, like this is good, I like this, I want to do more of it. Um, but either way, like there is a program, not programmed. There is a learned reaction from past experiences that is producing a particular emotion. Um, and the interesting thing about these is that those emotional reactions aren't always right, and um, this can be because like they were learned in a completely different environment. Like one of the things that I encounter a lot both in myself and in others is like they were learned in a school environment or a home environment where you had very little agency. So one of the things that I think a lot of adults struggle with is remembering I am an adult, I am not a child, I don't have to react to this in child ways, I can actually like leave the situation, I can stand up for myself, I can and solve this problem. Like the you have much more agency as an adult, but it doesn't necessarily feel that way when you're looking at an emotional reaction. um, and so there's something called coherence therapy, which is essentially about debugging this legacy code. It's about um, saying, okay, okay, where did I learn this? And and to be honest, it doesn't have to be 100% true if you figure out where you've learned it. It just has to be sort of like true enough. Like why might it have seemed a reasonable reaction to that response? And what are the relevant differences from the current situation um, and the situation which I learned it from? And then you can essentially like while the emotion is active by pointing out the differences that your pattern matching system should have picked up on, you can go, oh, okay, I guess I don't need to feel that way. And sometimes that works. And it's tricky and imperfect, but like it does seem to genuinely help people improve their emotional responses a lot of the time. Certainly it's worked for me.
Do you think So I'm resonating a lot here because I'm a software engineer and I used to be a software engineering manager,
Hmm.
and dealing with your people's, your subordinates problems is part and parcel of the job.
Hmm.
Um, uh, do you think there's something about being a software engineer, or like what is it about? This is a badly formed question, but like what is it about your approach that helps software engineers?
Um, I think there are a couple of things. One of them is that software engineers are honestly too prone to dismiss stuff that seems a bit fluffy or a bit too much. Like one of the things that is probably one of my more useful services is that I read texts from the humanities and then I translate them into terms that software developers won't immediately reject. Um,
Example.
um, uh, I think like the emotional stuff just now was an example. Another one was I was going to say I did a keynote for PyCon UK a few years ago in which I talked about James C. Scott's book Seeing Like a State, but
Mm,
actually software developers mostly like Seeing Like a State, I think,
yes.
or at least they like the blog posts about it. They don't like the book because none of them have actually read the book. Um,
That is so true.
yeah, which I sort of think is fair enough, but um, but let's think. So another example, which I know we've talked about a little bit in the past, is I have a blog post about uh, false negatives and false positives in interviewing,
Mm,
um, and a lot of my thoughts on that subject have been sort of informed by. Um, I guess that one wasn't so much, but it sort of comes from a lot of like the feminist epistemology literature, which is both like feminism and philosophy, and thus like software developers are not particularly likely to read academic texts on that, but um, but do like largely point to relatively concrete problems that people actually face. And so I think once you can explain them to people without using the word hermeneutical, they're much more likely to take you seriously. Because, of course, as we know, software developers don't like weird jargon ever.
that's that was a good joke. um, could you sort of, you referred to the idea, but I thought it would be useful to sort of like just talk about the idea of the whole that those, I think it was like two blog posts that you talk about hiring and false positives, false negatives, which
Mm-hmm.
are
Yeah,
terms that in the blog post you say you don't like to use.
yeah,
So could you explain that? Like,
yeah. Okay, so when you're hiring someone, there are two things that can go wrong, more or less. You can hire someone you shouldn't have, or you can fail, or that you can not hire someone who you should have hired. Um, and um, in the sort of the literature of false positive and false negative terms, a false positive is hiring someone who you shouldn't have hired. A false negative is not hiring someone who you should have. But I'll call them like bad hires and bad rejects, I guess. Is it? Um, and the thing is that you have like bad hires cause you a real problem. Like if you've hired someone and you shouldn't have, then um, best case scenario, you fire them, which takes a while, wastes a lot of your time, and like you're paying the money and they're causing you problems while they're there. Um, like worst case scenario is that you don't fire them and that they keep on forever at your company, costing you money and causing problems. Um, and this is a highly visible problem that causes you a lot of issues. On the other hand, if you have a bad reject, someone who you don't hire, who would have been great, you're never going to notice this. Um, you're never going to, no, I mean, you'll occasionally notice this, but like most of the time, what will happen is that you will say, sorry, we're not going to hire you, and then they will leave and you'll never hear from them again. Um, and so as a result, you have a um, very strong incentive to reduce your bad hire rate and the only thing that gives you an incentive to reduce your bad reject rate is that hiring is expensive. Like if you reject too many people who you shouldn't have, you might end up spending like an order of magnitude more on hiring than you otherwise would have. But like this is the sort of cost that is hard to understand. Like you'll just think of it as like, oh, well, fact of life, hiring is expensive. And the additional problem that I talk about in one of these blog posts is an ethical one, which is that you look for traits. If you look for traits that are good signs that someone is a good fit, but whose absence is not a good sign that someone's a bad fit, then this will look very good on the minimize bad hire rate metric, but look very bad on the minimize bad reject metric. So your classical example of this is looking for open source contributions on CVs. It's if someone has done great open source contributions, then it is probably legitimately true that they are a great hire. It may not be, like they may turn out to be a complete asshole, but like on technical skills, they are probably genuinely quite good. But there's all sorts of like problems with this in terms of disproportionate rates of participation in open source. Like I think open source participation is far more male than even background for software development. I don't necessarily think that in itself is a problem, because I also think open source is horribly exploitative, but like it leads to problems when we tie status to status and hiring to open source contributions. And in general, and like another classic example of this is only hiring people from top universities. Like many great people go to less top universities and get ruled out of hiring when they shouldn't have been. And so this is the problem I was talking about in this post, is there are all of these invisible ways that like add up on the false negative rate and are kind of unethical unintentionally, and we should pay more attention to. And also, like from a business point of view, are just stupid because, or not necessarily stupid, but like we're discounting the cost of them in ways that we shouldn't be by just sort of shrugging our shoulders and saying that hiring is expensive.
I think what struck me as like remarkable about that post is that you pointed out that this is just a natural sort of side effect of the problem, right?
Mm-hmm.
Like it's not, nobody's being evil, right? They're
Mm-hmm.
just sort of responding to the incentives that are in front of them, which is that hiring the wrong person is really painful because you have to fire them, right? And you have to deal with the fallout of like, the however long they stay with you, there are problems with that. And so as a result, and I feel this keenly, and as I was reading your post, I was sort of reflecting on my experiences because they evolve in exactly the way that you pointed out, that it would lead me or like any other hiring, ostensibly fair, ostensibly like somebody who wants to be good at hiring, just down the wrong path where we completely reject candidates that that are otherwise, like it's not just, it's sort of like a subtle thing that you were trying to point out, right? It's not that we were explicitly rejecting them, it's that they self-select out of the pool or whatever, and therefore like we have even more of a diversity problem in tech.
Yeah, absolutely. And yeah, I very much agree that like this problem is not caused by anyone being actively evil. I think it's an inevitable sort of unthinking following of the incentives. Like I think once you're aware of the problem, you can sort of start to sink in a bit of extra effort up front, and you will get access to all sorts of candidates who you would previously have excluded and rebalance to basically to have a lower false negative rate. Sorry, now I'm doing it. Lower bad reject rate. While keeping the bad hire rate more or less the same. It requires knowledge and a bit of upfront investment of effort. And the reality is that like probably it is still going to be the case that your bad hire rate is always going to be more important than your bad reject rate. But I think like putting in upfront effort to try and lower the latter is worth doing very much from an ethical point of view and arguably from a business point of view as well.
Sort of loop this back to your work with programmers. What other ways do programmers sort of like harm themselves without knowing it in their careers?
Gosh, that's a good question. I might need to think about that for a moment. I think the biggest one is they expect too much to work like programming. It's programming is very much this isn't 100% true, but like it's 90% true. Programming is very much a deterministic discipline where like you tell the computer what to do and it does it. And you are expressing things in a precise language and the computer is following your instructions precisely. And the data you're working with is all like already turned into a digital format that you can work with. It's unless you're sort of working at like the cutting edge of human computer interaction, like you're largely taking the way that a human interacts with a computer is given and only working with that digital data. And the real world is much messier than that. And often there isn't a single right answer. Often things behave in weird ways. Often things aren't going to be 100% right and you need to work with them anyway. And so I guess like there's this treating the real world as both having and needing more precision than it actually does. And I think you see this a lot in the sort of Hacker News commentator has discovered field and immediately solved it in 5 minutes style of comment. And that's sort of the extreme failure mode. But you also see this in sort of like the way that programmers argue, for example. It's like there is very much this demand for precision in cases that precision is probably not really what's needed here.
Could you give like a concrete example of like something that limits a programmer, maybe it's somebody you know, maybe it's yourself, in their careers as a result of their being a programmer?
I mean, as a result of there being a programmer is not necessary. But
that's
yeah,
not
it's
true,
like
but
the programmer mindset.
Yes.
Sorry, now I'm doing the unnecessary precision thing.
I'm used to it. I was a software engineering manager, so this is like bread and butter.
I should have a good answer to this off the top of my head, but I'm not sure that I do.
I'll give you my favorite, one of my favorite examples, which is that, so I have this term, fly fucking, which I think is from some European, I don't know whether it's from Danish or some European language, but it was a European hacker who taught it to me, right? And he said that it's very useful as a concept to bring up in conversations with software engineers when you're sort of debating about something, because the argument will usually be like somebody makes an argument and then they give an example, right, to support their argument, and the example is like slightly wrong in like some way, and then like programmers will pounce on it and then like argue over that completely irrelevant example for like 30 minutes, wasting everyone's time. And the right response is like, you're fly fucking, let's stop, let's move back to the main point. And the term fly fucking is like, the fly is so small, you still want to fuck it. So that's my favorite example as like when I explaining like to, like when this kerfuffle happens and there's a non-technical person in the room, I turn to them and say like, give me a moment, I'll explain to you what just happened. And then I go, and then I turn to the programmer and say, okay, you're fly fucking, stop, let's go back to the main point.
Yes, that is a good example, and I guess like another example in the programmers having argument space is what I think of as like the Vim versus Emacs debate.
Go on.
Or the static typing versus dynamic typing debate. It's And there are sort of like, there are two levels of this. Like one is just like the people behaving so convinced that there's a right answer.
Huh.
And the reality is that there probably isn't a right answer. And there certainly isn't a right answer you can logically argue your way into. Um, and then the sort of the next level of this is, okay, so why don't we have empirical data about this? Where programmers don't understand empiricism. It's because they think empiricism looks like physics. And the reality is that if you try to do a physics-style experiment where on data like Vim and Emacs, say, or static typing versus dynamic typing, it's almost impossible. So what you end up with is like the these really weak experiments which sort of gather like 100 students in a room and try a short task on them and see how it goes and conclude that maybe there's a little bit of difference, kind of, possibly, sort of. And these are, they will immediately pounce on all the methodological flaws with these. Not 100% inaccurately. Like it is true that these are probably they're only on inexperienced developers, yes, because experienced developers are super expensive. There's a relatively small sample size, yes, because even inexperienced developers are super expensive to run experiments on because they're people. And like it's over a short period of time, yes, because running it over a long period of time costs proportionately more. And these are all of the problems that you have when trying to do quantitative research on humans. And so and the reality is that you just have to bite the bullet and do qualitative research, do like ethnographic studies of what developers actually do. And they will probably never tell you that Vim or Emacs is better, because what they'll actually tell you is that both Vim and Emacs are awful.
What a way to end that anecdote. Maybe so here's an interesting sort of like follow-up question to that, right? Like if say we flip that, you have spent a lot of time helping software engineers where they sort of try to apply the programming mindset to too many things, and then it sort of limits them, whether it's emotionally with their emotional lives, or maybe it's like with their careers because communication and whatnot, right? But if I could flip that on its head and say, like, you are now presenting, or you're talking to somebody who's non-technical, who for whatever reason has to deal with programmers. Maybe they're a product manager, or maybe they are a CEO, in a firm that requires, like I said, large technical component. What would you tell them to help them sort of work with programmers better?
Oh gosh, that's a good question. I think so far, most of my clients at the executive level have been ex-programmers, so I have neatly sidestepped this problem by being the opposite.
Well,
I think that
no, go on.
The thing I would probably tell them is to think of programmers as like very systematic people. Like at their best they are. This isn't always true, of course, but and so it's actually, no, that's a good question. I don't have a good answer to.
I have a sort of simpler, I think. I just realized that there's an easier way of asking this. What would a novice get wrong?
When talking to programmers?
Yes.
I think the first thing that a novice would get wrong when talking to programmers is that they would assume that the programmers are much angrier with them than they actually are.
Go on.
Because there's a strong argument culture in programming, because like the Vim versus Emacs thing was an example of this, but those are the ones I think programmers are actually angry a lot of the time. But
that's really bizarre now that you've pointed it out. I've never actually go on.
Yeah. So the thing about programming is that For technical decisions, there is often like a right answer, or not necessarily like, should we do it this way or that, but like, why is this bug happening? What's going wrong here? Like, what is the actual outcome of running this programming? So programmers live in a world where like most of the time there is an objective truth and people are trying to come to the objective truth. And so like I think of mathematicians as the more extreme example of this, but like programmers are about 60% of a mathematician in this regard, where like if a programmer is arguing with you, it's probably because they want to understand and they want to get the right answer, not because they think you're a bad person for having said the thing you did.
What's another thing that a novice will get wrong in this way?
Um, I think the thing that as a programmer I've been most frustrated by novices getting wrong is that often they will assume that like they can understand more of what's going on in the technical decisions than they actually can.
Hmm.
It's like one of the things I'd sort of have as a general principle is that people understand problems much better than they understand solutions as to those problems. And particularly I found when working with, usually I found this with people who are in charge of the company, like CEO types, but is that they will have some very clever idea that absolutely will not work, and it will take like 3 hours to explain to them why they won't work, and they still won't get it at the end of the 3 hours. Um, and there are two parts to this problem. One of them is that they assume that they can understand it, and the other is that the programmer really wants to explain it to them.
It's so true. Oh my gosh.
Yeah. The first 3 times at least. Afterwards, it gets old. But
yes. Okay, so basically, if you were a non-technical person and you're dealing with programmers, well,
Mhm.
this is good advice. Like, you should not try to spend your time that much in the solution space, is what you're saying.
Yeah,
Instead, spend all your time explaining the problem to the programmer.
yeah.
Oh, that's really good advice. Okay, I'm gonna segue a bit and backtrack a bit, and sort of ask you: were there anything that you learned from your hypothesis experience that you brought into your coaching and your coaching experience that you're doing
Mhm.
now?
Yeah. So there are a couple of things. Like I find myself drawing on technical analogies from hypothesis surprisingly often and finding them useful surprisingly often, which I think is a result of like my brain is very good at drawing connections between things that work pretty well, but are not necessarily like the thing that you would come to if you had like a sensible background. So an example of this is I have a post on my notebook, Life as an Anytime Algorithm. Um, an anytime algorithm is an algorithm that is trying to do something and it's trying to get like the best possible thing. Um, uh, but also at any point you can stop it and say, hey, give me your best answer now and just stop working. I don't care anymore. So, for example, shrinking, which I talked about in hypothesis
Hmm.
earlier, is your classic example of an anytime algorithm where it's got some test case and it's trying to make the test case smaller and simpler. But like it's doing this to save you time. And if it has been doing this for an hour, you're probably bored now, and you want to say, look, just stop, give me what you've got. I really don't care about like the last 2 bytes you're shaving off the answer. Um, and usually you want to stop it long before an hour. Um, but this is an anytime algorithm where like you're designing to get the best possible result eventually, but you're also designing it so that it makes useful progress along the way, and it at any given point you can just cut it off and say you're done now. And so I've often found it's very useful to structure life projects as an anytime algorithm, where like you are trying to achieve some grand goal, but also like you acknowledge that you might just get bored or you might sort of decide it's no longer worth the cost at some point, and you want to make sure that when you do that, you're walking away with something that you're proud of.
That is good. That is really good. Wow. I think,
Um,
yeah, you go on.
no, sorry, go on.
I was I was gonna say one of the this sort of like highlights one of the things that really attracted me to your writing, which is that you have a very rigorous, I guess rigorous is the right word for it, right? Approach to self-improvement and life
Mhm.
skills and learning. Um, Maybe sort of to start off this section of your work, could you talk a bit about like how or why you think you're effective at those set of topics?
Uh, yeah, so I guess one thing I would say is rigorous approach, but haphazardly applied. Um,
Go on. What do you mean by
it's
that?
what I mean is that I essentially like the rigor is often added after the fact. It's I work on whatever feels important to given point, and I tend to sort of jump from topic to topic based on like what I currently have the sort of the highest cost benefit analysis of. There I am doing it again, but it's um, but I think like one thing that happens a lot if you sort of look at my writing from the outside is like it seems to jump from topic to topic. Like this week, I'm talking about I can't even remember what the last newsletter post was about. Uh,
Chopsticks.
Chopsticks, yes, exactly, yes. So that was the post about me teaching you to use chopsticks. How's that going, by the
Yes.
way?
Haven't bought it yet.
Okay, fair enough.
So for listeners who are listening to this, the post about chopsticks is about learning, and I don't know how to use chopsticks properly, and David suggested that I buy cooking chopsticks, which is large, and that's a way of sort of like a lateral move into learning the thing because you're sort of changing the context.
Mhm.
But go on.
Um, Yeah, so but this is a perfect example of the writing thing where like we had a conversation and it resulted in me writing something. And as a result, I will probably like the lateral move approach is more at the forefront of my mind, so I'll probably be on that train for a little while, or I might hop over and like base something off the latest book I'm reading. So it's very sort of scattershot, do all the things, but as part of this anytime algorithm approach, like what happens is that when I figure things out, I write about it. Um, and I think the practice of writing about things as I figured them out is very much what drives this analytical, rigorous approach. Because um, partly because I am coming from a background where I'm used to explaining technical concepts clearly. So like this is just how I explain things. But I think it by its nature it produces this sort of set of like really nice usable tools um, to have the constraint of being able to explain what I'm on about in a single like relatively self-contained essay.
Could
Um,
you sort of give listeners an example of that, like one example of the many posts that you've written in this self improvement area?
mhm. So I think like the foundational one I wrote, which was back in 2019 before like I really started the self-improvement writing kick, is called How to Do Hard Things, um, and uh, is like there's an interesting thing that happens when you write too late, like once you've already internalized the idea. Like while I was writing it, it felt very boring, and like I was just explaining something obvious, and I was just like, oh god, people don't need to hear this, they know this, right? And that was not the case. That one landed at the top of Hacker News for a while, and is I think my second most popular piece of writing, the first one being a piece of Stargate fan fiction. But are you not familiar with my work in
I
Stargate fanfiction, Cedric?
absolutely not familiar.
Yeah.
I buy chopsticks. Yes. Go on.
So the Stargate fanfiction, of course, being my other great age contribution to world of software testing.
Wait. So go on about how to do hard things.
Yeah. So how to do hard things is essentially when there is something that is too hard for you to do, find something like it that and like it's hard enough that just trying it doesn't get you any traction. You find something that is easy for you to do, and you make it hard in exactly one way that is like the hard thing. Um, so if you are struggling with writing a book, write a short story. If you are struggling to juggle, try just like tossing a ball up and down in one hand. I mean, that's not strictly an example, but like the point is find something easy that is easy for you and sort of like try and draw a path in the direction of the hard thing. Um, and I think this is part of why I have this haphazard approach in some ways, is that like I am always finding something easy and sort of taking the next step from there. And often that is in the direction of some grander goal, but like from the ground, that isn't necessarily obvious.
Well, this is really interesting. Was this, you think, this approach, did it inform your approach to hypothesis? Because I'm sort of seeing parallels here, you know?
I think that was written after I had done most of my major work on hypothesis.
But was it something?
So was it something that informed?
Yeah.
Hypothesis was much more done in a solve the problem in front of you sort of mindset, where it's I had this thing that existed and was working, and so it was a similar incremental approach, but there wasn't some overarching goal I was reaching towards particularly. It was much more I have a practical problem that I want to solve in the and hypothesis in its current form is sort of infrastructure for solving that problem. But
right. So this how to do hard things, like from which part of your life did it come from?
To some degree, all of my life, I think. Like but I guess like the two main things that I practiced it most on are software development and writing. I've been continuously improving at both for most of the last, let's say, 15 years. It's closer to 20 years, but and a lot of that has been not necessarily at all times with a single overarching goal, but it has been very much this take an easy thing and make it harder approach. And sort of like continually pushing the boundaries of the comfort zone to try to improve at the skill.
So one thing that you've mentioned in the past is that you are pretty good at explaining computers, and this sort of like ties into everything we've talked about before. And I think you're writing a book about that, right?
That's the plan. It has been slightly shelved this month because this month was the point where I was going to be focusing on it, and then I got a bunch of potential clients for the team training stuff, and so I've been a bit more focused on that. But it's a thing that has come up in my writing and sort of a bunch of times, and the starting point for the book is to assemble a bunch of essays I've already written about it and try and fill in the gaps and expand upon them.
Could you sort of say more about what's the pitch and what are some of the approaches inside the book?
So the basic pitch is that you need to. So I wrote How to Explain Anything to Everybody, a blog post a while ago, where essentially the core concept of it is that in order to explain something, you need to put it in terms that they already know. And this is the single biggest thing that programmers fail at when trying to explain technical concepts, is that they assume people know things that they don't know. So you heard some of this earlier when I was explaining hypothesis to non-developers. I started by going, okay, so first let me tell you about software testing.
Yes.
And that is an example of something that I have learned slightly the hard way. That you need to first check in with people to see if they understand before explaining hypothesis. And so the how to explain computers is about providing people with sort of the layers of scaffolding they need to understand and understand something. And this can be this can be either to give someone a complete understanding, like teaching someone to go from novice to developer, or it can be explaining the problem to someone, or it can be giving people sort of like a sense of the thing. And it's also to a large degree about communication skills. Here, I'm going to put you on the spot. Suppose I come to you and say, as a non-technical person, as you well know, like obviously I know nothing about computers, and say, Cedric, what's a web browser?
Oh dear. Web browser it's Chrome. It's a thing that you use to view web pages.
Okay, it's
I'm sort of making a face here for if you're listening on the podcast, because like it's really hard, because as a programmer, like all these concepts just suddenly exploded in my brain. And to sort of like make a sort of to sort of tell a funny story about this, there was once a workshop that I did in university when my friend and we had a bet going, like we would not mention, and the workshop was to teach the basics of HTML and CSS, which are these sort of basic building blocks of making websites, right? And we had a bet going, like whoever said the word DOM once would have to pay the other person. And thankfully I didn't fail. My friend failed. And for non-programmers listening to this, the DOM is the representation. Oh, this is terrible. You're really putting me on the spot here. It is the thing that the browser constructs in order to show you the web page. It's totally unnecessary. You don't need to know anything about it. Yeah.
Yeah. So this is a question that I posed when I was giving some lectures in academic writing a while ago, and I did come up. I don't remember what I said at the time. I did come up with what I think was a reasonable explanation of a web browser to non-technical people, and then I pointed out that this was the wrong answer, because the right answer is, why do you want to know?
Oh my god! Oh my god! That is so true. That is so good.
Because if you launch into a technical explanation of HTML and CSS and so on and so forth, so one thing you did right, which was good, by the way, was that you said you gave a concrete example to start with. You said Chrome, because like my prototype answer for this is like, this website is telling me that I need to use a supported web browser.
Ooh, wow. My answer will completely change if somebody was asking with that context in mind.
Yep.
Oh, oh, wow. Wow, I can totally see now why, yes, companies should hire you to teach programmers to communicate better with the rest of the company. Good. Oh my goodness. Do you have another example in this sort of like category? This is amazing.
Someone once asked me what a programming language was, and and here there's no trick to this. Like, he was genuinely just curious. The context was that he was the son of someone who was at a Python conference with me, and so like he was there essentially like. We were in Namibia at the time, so he was there partly for the holiday and partly, I think, because like it was an interesting learning experience for him.
How old was he?
It's a good question. He was late teens.
Right.
I think somewhere in the 16 to 18 region, I think. And I asked him how much detail he wanted, and like whether he had some practical question in mind here. And the answer was that he didn't have a practical question in mind here, and he wanted a lot of detail. So I walked him essentially like down the whole stack. I was just like, okay, so a computer is a machine that follows a series of instructions, and like it's got various things, like it's got RAM, which it can store information in, it's got a CPU which executes these instructions, and by default these instructions are just like this incomprehensible stream of numbers that don't make it, like, you can't really read as a human. So what we want is to be able to like take something that a human can read and translate it into these series of instructions. And I went into a lot more detail than that, but that's the basic idea. Um, and one of the other programmers was sort of sitting in listening, and he was just like, it's interesting. I was waiting for you to use a big word that you hadn't explained, and you never did that.
Incredible. I think
Um,
so. If for those of you who are sort of listening, like the really mind-blowing thing for me was David explained to me what the mental model was for people who were good at math. And the context here is that I am horrible at math, and I was never good at it. I struggled with it in school, and like the main reason for that was in secondary school. In my very final year before the school leaving exams, like there was I still remember the class where like the teacher was like, I forgot to teach you trigonometry. And there's no time. And there's no time left to teach you, so I guess you have to like, let's just pray that it doesn't come out in the exam. And it didn't, thankfully, and I got an A. But then like forever ever since then, right? Like and I think the way you put it very sort of succinctly was, math is very unforgiving. If you lack a foundational pillar, right, you will suffer when you start going on to pre-university and then university. And that was exactly my experience.
mhm.
And the way that you sort of explained to me, and I'll let you sort of like explain it in a second, is like people who are good at math don't do what you think that they do. Everybody thinks that good math people just do, what they learn to do in secondary school, which is to regurgitate learned rules. And David, perhaps you should explain this, because this was quite profound to me.
Yeah, so I think your typical experience of someone who ends up being good at maths is that in about the first 5 minutes of the class, they go, "Oh, I get it now." And then the teacher keeps speaking for the rest of the class, and they zone out and think about something else. Um, and the problem with the model that you try to learn in school is that you memorize maths as this long list of like facts and rules and rituals to do, and no one ever actually explains to you what's going on. And um, there's a I'm a big fan of like a paper by Lockhart called "A Mathematician's Lament," which basically complains about the deplorable state of the mathematical education. And there's this great line in it about how everyone thinks that they understand the problem, and the teachers say we need more funding, like the government says we need more discipline, and the students say math class is stupid and boring and I hate it, and they are the only ones who are right. And mathematics is it is a body of working knowledge. Like you learn mathematics in order to do things. Like you solve problems, you spot interesting patterns, you try to figure out those interesting patterns. And you fit everything together. Like when you are like if you try to like I can't remember the quadratic formula off the top of my head, but I could work it out.
Hmm.
And the fact that I can work it out means that when I am using it on a regular basis, it will not be difficult for me to remember it because like because I don't get to a point where I'm using the quadratic formula or I need to use the quadratic formula and I can't, and then I'm stuck and I don't, and as a result I get no practice in the quadratic formula. Instead, where I go is like, oh, I think it has roughly this form, and I know that this is roughly how the proof is going. I'll just complete the square. You'll never have heard the complete the square in your maths class probably, but like it's a very simple proof step which is how you work out the quadratic formula.
Good Lord.
And so by knowing all of these intermediate steps and sort of treating mathematics as just like a working skill, which I'm actually using, it's by doing mathematics I get better at mathematics, rather than by doing mathematics I apply the things that I've already learned. And you barely ever do mathematics in this sense in school. Like you're never really told how to prove things to you do some proof in geometry, but like even the proof that is badly explained and tends to be like the class people hate the most. uh, and um, and so there is a lot of sort of like mindset of how proof works and how knowledge fits together that um, no one ever sits you down and explains the bare facts to you. And
Yes.
this is I think it especially bites people in mathematics because mathematics is so abstracted from anything that people are actually doing that uh, yeah. So this is the other thing that I think is like my version of Lockhart's thing of maths class is stupid and boring is that like in class people ask when am I going to actually use this, and teachers treat this as like an invalid question, but no, this is the correct question. It's you if you do not find it interesting and you're not going to use it, you shouldn't be learning it because you won't actually be able to remember it. Um, and using it is how you remember mathematics.
Yes. I think why your explanation was so resonant was because so I did a computer science degree. You did math, right, in
Mm-hmm.
university?
Yeah.
Yeah, so we had I think five classes that was math, right? And they were really good math people in the class. It was in the math
Mm-hmm.
department. It was taught by math lecturers, math professors. And they did exactly what you described. I noticed this, right? They were like, okay, I got it. And then they're bored. And then like they're off doing other things during class. So when you
Mm-hmm.
described that, I was like, that must have been what was going on in their internal world.
Mm-hmm.
And everything you said about like they worked it out as a body of working knowledge mapped 100% to whenever I went to these people for advice, for help, right? They had this very intuitive sense of the problem. they,
Mm-hmm.
they weren't the way I could tell that there was something very deep that was going on, some sort of cognitive process that I had no access to, and I had
Mm-hmm.
no idea what it was until you explained it. And so
Mm-hmm.
now I wish I could have gone back in time and sort of like told my younger self like this is what actually they're doing and this is how you get good at math.
Mm-hmm.
Oh, how did you come up with this, or like how did you stumble onto this?
Um, I don't remember my school maths classes enough that I can properly answer that, but it's the honest answer is just that I'm quite smart. I and I didn't have much better to do with my time, so I don't know. It's like um, not to say that you're not smart, of course, but like it very much like from my from my perspective, the thing that was happening in maths class was that I they just weren't teaching me anything very hard. So I essentially had a lot of time. Like, I think there's an important thing with learning in general, which is that you need slack time in order to actually sit and integrate it. You can't just sit there and take in information at the rate it's being given to you. You actually sort of sit and process it and so on. And so I think with mathematics in particular, or because of how much it builds on itself, but with everything really, like if you are better than is needed to be for the material, then you will have this experience of sitting in class and essentially like having that slack time built into the class because you don't need to pay that much attention. And this then compounds as an advantage because you have a solid foundation to build on for the next phase. So like if uh, you what you did in the previous step of like properly integrating the material that you're now building on means that you have the an even bigger advantage in the next phase. So I think like it is a mix of intelligence and luck early on,
Mm,
and having like a decently mathematically shaped brain.
yeah.
Um, and um, and I couldn't have explained any of this to you until probably like the last 5 years. It's like I knew intuitively that this was what was going on, but until I spent a lot of time talking to people and reading literature on skill development and expertise and
Right.
trying to fit together like what it was that people were actually struggling with, I couldn't have explained my own experience in this way. But because I think like at the time, mathematics just felt kind of obvious, and I didn't really start struggling with mathematics until my third year of university, which turns out is an unfortunate year to start struggling because they assume you know how to do hard work for it at that point. But
Yes, yes.
um,
So I guess we're nearing time right now, and I just wanted to sort of like shift the conversation to the last bit where we get to talk a bit about your current practice, where you're trying to start doing what you do for individuals with organizations and teams. Could you talk a bit about like what you hope to accomplish there and what's going on right now?
yeah, so what I hope to accomplish there is I've worked in a number of different software teams, and I know like how to help software developers with their problem solving and soft skills quite well at an individual level. And it's just very clear to me that like a lot of teams are, even like very good teams, like they have some area that they're struggling with, and having someone who can come in and essentially say, hey, what's up? What are the problems you're facing? Um, shall we like look at them and solve them together? Is good for like I think it's a thing that most teams would benefit from. Um, and to be honest, I expect that the teams will do about 80% of the work, because possibly more than that. And my role coming in will be to um, do essentially facilitate and give them like the nudge in the right direction that is needed to make sure that what they're doing is the right work. Because it's partly because I've gotten good at that, helping individuals. I've also been doing some more executive style coaching with a CTO and a senior software developer. And so like I'm reasonably confident at this point that like the things that I had developed largely for solving life problems work pretty well for business. I mean, if anything, the CTO I coach is my easiest client because there are so many problems to talk about.
Wow.
I mean, that's not entirely like that makes it sound bad. Like I just mean that like a business is a
Yes.
large complex entity. Like if anything, his business seems unusually good, and there's still a lot to talk about.
No,
Um,
definitely. Like I resonate with that as well because there's always a fire to put out in the
yeah,
business, and when you put out the biggest fire, there's like a second biggest fire. There's
yeah,
always a
yeah,
fire.
exactly. It's like the universal constant of business is that something is always going wrong and something could always be better. Um,
Yes.
and um, I think there's a thing that Gary Klein says at some point in one of his books about how working on team cognition is so much easier than working on individual cognition because like all of the moving parts are visible to you. I can't look inside your brain and see what's happening, but I can talk to your team members and talk and ask them what they think is happening. Um, so I think,
To make this more concrete, right? Like I think we've sort of articulated one key value. I would have loved to hire you or someone like you to talk to my programmers and get them better at talking to non-technical
mhm,
people in my
yep.
company.
Mhm.
That's sort of like one aspect of it. What other aspects are you sort of like good at helping?
So one concrete thing that I'm hoping to help people with is sprint planning.
Oh,
Like
interesting.
I think that people are bad at understanding the dynamics of sprint planning. And so a simple example of this is that um, when you exceed your like when you don't get all the cards done from a sprint, that's a problem, right? How big of a
Yes.
problem is it?
Depends, right, on what else is going on.
um, yeah, so I would argue that like you should treat it as a much bigger problem than people traditionally treat it as,
Huh.
because this partly ties into the thing I was saying of Slack in learning. Like building Slack into your systems is a good way of ensuring that everything works better. People are learning better. People are doing better work. People are able to deal with unexpected contingencies. Um, And so when you exceed your sprint goals, that is both a sign that you have significantly overestimated how much work you can get done in a sprint, and it's also a sign that you are running with no slack. And so if you get to a point where essentially you are to within rounding error always, unless like some genuinely once in a blue moon catastrophe occurs, completing your scheduled task for the sprints, then what you will probably find is that everything will work better. And over time, the amount of work you can get done will, without exceeding your sprint goals, will go up. And so like the sprints will actually become more productive by doing that. And as long as you are routinely exceeding your sprint goals, you will end up in what I refer to as the too busy fighting fires to invest in firefighting infrastructure problem. Like everything will be on fire all the time, and as a result, you will be significantly less productive than you could otherwise would be. And also, all of your team is stressed, and also management can't predict what is reliably going to happen.
Wow. Okay, that makes a ton of sense. I did not think about it like that. That's really cool. All right. So thank you, David. It's we're at time. I enjoyed this a lot, and I learned a lot from this.
Well, thank you very much, Cedric. It's been a pleasure. I enjoyed it a lot too.
All right. I hope you enjoyed that episode of Commonplace Expertise. If you like it, I will be very grateful if you left a review on Apple Podcasts or like and subscribe if you're watching on YouTube. David, if you want more of him, may be found on Twitter at Dr. MacIver, and his newsletter, where you can read his writing on self-improvement or soft skills for hackers, programmers, may be found at drmaciver.substack.com. I've linked to both in the show notes if you are listening to this on your podcast app, or below in the description if you're watching this on YouTube. Thank you for watching or listening, and I'll see you in the next one.